Good morning, my name is Mengyang Wei. I'm very excited today to give this presentation introducing the work I have done during my PhD study. The title of my PhD project is that study of the banking system's stability using control theory. As this is an interdisciplinary project, I have three supervisors from different research areas. Dr. Gianluca Marsali, he helps me throughout all the project, from building the model to analyzing the results. Professor Miguel Ledesma from the School of Economics, he advises me on the economic side, such as microeconomic modeling and financial regulations, and helps with the model validation. Professor Sarah Spurgeon, she advises me on control analysis and control design. My presentation today has 6 parts, corresponding to the 6 chapters in my thesis. First part is the introduction of the project, including the motivation and the main contributions of the project. Second part gives a brief background information, including some of the existing literature that related to this project. Then I will present some details of the dynamic network model, followed by some simulation result. The fifth part shows the control analysis with some test result. Last part will be the conclusions and the future work. The background of this project is the 2008 to 2009 financial crisis, which shows that the banks should be regulated at a system level rather than individual level. The financial crisis exposed the risk of contagion caused by the links between the banks. A failure in a small number of banks can spread to other banks through interbank loans, then causing the paralysis of the whole banking system. There is a need then to give special emphasis to systemic risk. Financial regulators have now adopted a microprudential policy to mitigate the risk of the financial system as a whole. The motivation of this thesis is to try to find new ways to model and analyze the dynamics of the banking system. This thesis presents an interdisciplinary research at the interface between economics and control engineering, aiming to provide tools to better understand the banking system's dynamics and the corresponding systemic risk. These tools including network models and control theory. The network model proposed in this thesis is based on ordinary differential equations, and it incorporates the interconnected nature of the system. This model also facilitates the application of engineering control theory, which can suggest ways to reduce occurrence of systemic failure. This thesis contributes to the knowledge and research in both network models and control theory applied to the banking system. The contributions including development of a dynamic network model of the banking system and the Simulink block diagrams of the network model, as well as the application of the control theory analysis. The novelty of the approach consists in developing a model of banking system based on differential equations and in applying control analysis to study its stability. Next, I will introduce the background information in 2 parts. One is the network models, and the other one is the feedback control theory. The financial crisis has drawn a sharply increase in academic research, which has used network models to study the financial system and to propose ways to preserve financial stability. The banking system can be modeled as a network where nodes are individual banks and edges are loans between any 2 banks. The existing work using network models to study financial systemic risk is quite diverse and also fast-going. Papers on this topic usually carried out the network models analysis using one of the following 2 distinct approaches. The first one is the static network analysis, and the second one is the dynamic network analysis. Static network analysis uses tropical indicators to describe the network structure, such as degree, strength, and density. This kind of analysis does not include a mechanism by which shocks are transmitted. For this reason, it is referred to as static network analysis. The second approach focuses instead on modeling how different network structures react to shocks in order to identify the key factors that affect the resilience of the network. This approach usually involves a dynamic simulation to model how default spread in the network. That is referred as dynamic network analysis. The model of the banking system proposed in this PhD project belongs to the dynamic network analysis, which involves simulations. There are 3 papers which are closely related to this PhD project. The paper by Yori studied the performance of the interbank market in its role as a safety net by simulating interbank lending. The work shows that the size and the connectivity affect the contagion. It should be stressed here that the initial differential equation model developed in our model was inspired by the difference equation model developed by Yori. Works by May and Hayden explored the interplay between complexity and stability in simplified model of the banking system. The structure of the model in these papers was extended and used in our work. Control theory is an interdisciplinary field of applied mathematics and engineering. Controlling a system means to influence the behavior of the system in order to achieve a desired goal. Feedback is a key concept in control theory. A feedback process takes the system output into consideration and enables the system to adjust its performance to meet a desired output response. Nowadays, as the understanding of the dynamics of business, social and political systems increases, control engineering is not limited to only engineering discipline, but is equally applicable to these systems. As the general theory of feedback system, control theory is useful whenever feedback occurs. Therefore, in this thesis, we proposed to apply control theory to a model of banking system with the aim to study its stability and try to control it at a desired state. This is a block diagram of a negative feedback control system. It illustrates the concept of using a feedback loop to control the behavior of a system by comparing its output with a desired value, called reference input, and applying the difference as an error signal to dynamically change the output so it is closer to the desired behavior. Here is a block diagram of an automobile steering control system. The error is the difference between the actual cost of the travel and the desired cost of travel. The driver adjusted the error by using the steering wheel to control the car so that it travels on the desired path. It can be seen from the feedback control system that the control engineering has the ability to deal with uncertainty as the system can reduce the error without the knowledge of why the error occurs. For instance, the driver may not know why the car has diverted from the desired path, but he can still bring it back to the desired path. Therefore, the initial motivation to design and apply a control approach to model the banking system is to expect the control approach to bring the banking system back to stable when the causes of the instability in the banking system are unknown. The existing literature shows that the control theory has been used to analyze financial problems. Here are 3 papers which use this feedback control to analyze the economic system, financial system, and the stock trading